Hi, good morning and welcome to the European Utility Week here at the Engerati studio on the exhibition floor. I'm Volkwyn, editor of Metering and Smart Energy International. And with me this morning I have Bengt Stahlschmidt from Gildemeister.
Hello.
Hi, Bengt, thanks so much for joining us. Tell us a little bit about Gildemeister and particularly about CellCube.
Yeah, so Gildemeister Energy Solutions is a daughter company of the well-known machine tool manufacturer DMG Mori-Seiki. They are the market leader in the world for machine tools, and actually they started in 2009 to invest in kind of renewable energy and have activities there. And over that they also acquired a company where we are in making the CellCube storage system. And these systems are manufactured in Austria, south of Vienna, and from there sold all around the world.
So, energy storage solutions, what is it about the one that you're offering and the technology that you're using that makes it so special?
Yeah, so energy storage in general, we can say, when we look to the whole energy market with renewable energies, the power is not always available when we need it. So we have to kind of store it, and that was also the reason why DMG at that time invested in this technology and solution. This will be a very fast growing market. And we have a lot of technologies everybody knows, like lithium-ion batteries, lead-acid batteries. And then we have technologies where we are not so familiar with, like for example the vanadium redox flow technology, which we are using in the CellCubes.
Okay.
And we have to see that every technology has its market area where it's fitting very good into, and some areas where we really have to say, no, it's not fitting. And so for the vanadium redox flow technology, very general, we can say it is when you need a lot of power, but in addition, you need also a very high capacity. Because when we look to the technologies I mentioned before, like lithium-ion or lead-acid batteries, you have always power and capacity in the same ranking. So that means when we have 10 kilowatts, you have 10 kilowatt hours. If you want to have 20 kilowatt hours, you also have to increase your power to 20 kilowatts.
Okay.
And the vanadium redox flow technology has the big advantage that it is power and capacity separated. So you can say, I want to have a 10 kilowatt system and you want to have 100 kilowatt hours. And this we do because vanadium redox flow is an electrolyte. So you have one tank where you have the electrolyte in, and you have one area or one container where you have the whole electronics and the power management in, what we name the so-called stacks. So what we do is basically we pump the electrolyte through the stacks, and by that we generate power or we give it up to the grid. So that means we can store it, turn the electrolyte to plus, or we give it back to the grid and then we turn the electrolyte to minus. And that is already one point by just saying that is when we have only an electrolyte to be pumped through, that we have an unlimited number of cycles. Because there is nothing which is continuously changed, it is just an electrolyte.
Okay.
And so what can, be ruined after 10 years or 15 years is basically the pumps. But these are normal industrial pumps, and the rest of the system will just continuously run.
So now, what makes this particular product additionally interesting is the fact that it is applicable not just across one type of application. You mentioned that there are numerous applications that your energy storage system can be used for. Can you elaborate on that a little bit more?
Yeah, well, in general we call about the Gridscale market and the microgrid market. And by having the technology that we have power and capacity separated, the systems are really easy scalable. So that means when I want to have more power, I add more stacks. When I want to have more capacity, I have the more container where we have the electrolyte in. And for the Gridscale market, there are huge problems coming through the renewable energies, which are continuously increasing. So when the sun is shining, we produce a lot of solar. Then there is a lot of power coming on the grid. And then the grid is getting more and more unstable because at a certain point the grid cannot just take it.
Yeah.
And in Germany, for example, we had in summer 2012 the first time that companies were asked to take away power from the grid and get money. So you were not paying for your electricity, you got money when you consume it in a certain moment because they just didn't know where to put the energy. And that is where in the Gridscale market storage systems are coming in, and with the vanadium redox flow technology we can have multiple megawatt solutions for storage and with a much higher capacity. So in that case we are connected to the grid for grid stabilization.
Okay.
And also for shifting the times when you can use the generated energy, because the sun and the wind were there during daytimes, and in the evening and night hours there is no sun. So in that case we can feed back to the grid out of the storage systems. When we are coming to the microgrid area, the biggest business field in the moment is when you have real microgrids driven by a diesel genset, and the diesel, the handling is, as we talk about rural areas, is very, very expensive because there is no gas station just around the next corner where you can get your diesel and fill up the tanks. You have sometimes go hundreds of kilometers, or we even had one application where the diesel was provided by helicopter. And
okay, that's really not very close to
right.
to the normal run-of-the-mill grid solution.
Right, and that's where we can say just when you have your microgrid, which is diesel driven, then and you add a storage system to that microgrid, by that you have the diesel running in his optimized returns, and the delta of produced energy is not blowing up in the air, it's going really into the storage system. And just by adding the battery, you can roughly say you reduce the diesel runtime between 6 and 8 hours in a 24-hour window. So that means, just for one example, you charge it during daytime, and during nighttime when you want to sleep, you can power off the diesel genset, and the whole net is provided just out of the battery. And that is one advantage of our storage system, that we can steer the diesel genset. So we can tell the diesel genset, hey, the battery is full, please power off. And also when the battery is going to be empty again, we can tell the diesel genset, hey, you have to start again.
Okay, so this is an application that you can use on the grid, you can use on a microgrid, and you could also use it then, I guess, for adding capacity to rural electrification operations as well.
Right, exactly. So when we just stay to the microgrid, where we have been just before in the sample, so in the first step, it is a matter of trust. The diesel is there for the last 40 years. You are used that the diesel is running and running. So you will not start with a battery capacity and power, which is your final solution. You first want to have a kind of trust of the new concept and the new idea. So that's why you start with a smaller storage system and just take always the delta from the diesel genset. Then after half a year or a year you feel familiar with that, then maybe you start to add solar. But then, when you want really to provide it fully from a storage system, you have to increase the power and the capacity. So you need the scalability of our system and add more electrolyte to the solution. And with the solar, suddenly you can figure out, wow, I can reduce my diesel runtime to 2 hours a day. And by adding a bit more solar or a bit more wind, then suddenly the diesel is no longer needed. It is just a backup system when there is days of very bad weather. And we have already installed over 100 systems in 76 locations all over the world. So that is showing that also we have locations where we have more than one storage system installed already. And this is going, the most north one, when I remember correctly, is Labrador. And so with very cold temperatures and rough area. And on the other side, yeah, also very rough, it is desert in Abu Dhabi.
Okay, so definitely tested across a number of very extreme environments.
Right, and that's another advantage of this vanadium redox flow technology, that the area where you can operate the battery as we deliver it, because we are not only delivering a standard or a base storage system, or like batteries or cells. What we add into a containerized solution is also all the power management, also all the converters and inverters from AC to DC and backwards, and also all the charging management. What do you need? So is it diesel substitution, or is it grid support? Because that is a complete different management software tools you need behind that. Also, we have the housing included. So that means it is an isolated standard container, and with this we can cover an area from -40 to +50 degrees as average temperature over a certain timeline. So that means when the battery is continuously running with a small heating or a small cooling, we have an operational window of 90 degrees Celsius in temperature differentiation.
Okay. So the thing is, I mean, obviously the fact that you offer the energy management and the conversion as part of the standard offering is fairly unique. But this system, you mentioned to me that it was pretty much a plug-and-play system.
Right.
How easy is it to integrate into your existing grid setup or microgrid setup?
It's very easy, as we are really delivering the container, so storage system plus all the storage management system plus the housing. So you have to do some groundwork where you can put the containers on, because the vanadium electrolyte is quite heavy. So that means we talk, even on a small 20-foot container, we talk already about more than 20 tons of weight. So you need a proper groundwork, and you need an earthing. And basically that's it. And then you plug it to your microgrid or to the grid, as all the power management is already integrated in our solution.
Okay. Is there anything else that you'd like to add about what CellCube is and what it can do?
Yeah, I would say in the very beginning we talked about that really the differentiation between power and capacity, and that it is a really flexible system. I think this is the key advantage. So when you need storage and to provide later the energy for a couple of hours, that we talk about 3 hours, 5 hours, 8 hour solution, or even longer, then it has a huge advantage compared to other storage technologies. And that is basically the business field and business area where we are positioning our storage solutions.
Okay, thank you very much.
Thank you, Claire.
Bengt, thanks so much for spending some time with us from European Utility Week. I'm Claire Volkwyn. Thanks very much.